Hey, this is Mr. Ward, and since there's some content on the exit ticket, which should not say 27.3, I will fix that. It's 28.1. I'm going to go ahead and help you with this stuff. So multiply out or expand y equals x plus 3 times x plus 3. Well, we've got to multiply x times x and 3 times 3, of course, but we also need to multiply x times 3 and 3 times x. And we got to put all that together. It's all positive, so I can just say plus, plus, plus. And what I'm doing, of course, is I'm doing x times x, and I did 3 times 3, but then I did x times 3 and 3 times x, which are actually both the same thing. So I'm going to have x squared plus 3x plus 3x plus 9. Okay, and then that boils down. I can combine 3x and 3x because they have the same variable with the same exponent. They are called like terms. And I get x squared plus 6x plus 9. And there is a pattern to this. You might notice that this is just x plus 3 squared. When I have a linear equation squared, what I'm going to end up with is the square of the first term, the x. I'll have the square, that'll get me the x squared. I'll also square the last term, which is the 9. And then I'm going to be doing 3 times x twice. So I'll do 3 times x and x times 3, which is the same as 3 times x. So I may as well just say 2 times 3 times x, which is that 6x. So when I'm just squaring a linear equation, I can square the first term, I can square the last term, and then I can just multiply the first and second terms, the x and the 3 in this case, and then double that because I'll be doing it twice anyway. Okay, let's take a look at the next one where we are going to be multiplying out x minus 3 times x plus 3. And once again, of course, I'm going to do x times x, and I'll do negative 3 times 3. And then I'll do x times 3 and negative 3 times x. So let's see what that gets us. We get x squared, and then we've got a negative 3 times 3, which will be a negative 9. And then in the middle, we're going to get a x times 3 and a negative 3 times x. When I put all that together, and it's all, these minuses mean that that's going to be subtraction there. So I'll be subtracting. I mean, you could think of it as plus minus, but it ultimately ends up being subtraction. That's addition. And so I've got x squared plus the x times 3 is just 3x. It's by convention, we put the number first, minus 3x minus 9. So you might notice in the middle, we got a 3x minus 3x. That's just a whole lot of nothing. So we're going to end up with a 0 there. So x squared plus 0 minus 9. Oh, that's not a minus. That's supposed to be a minus. And then that ends up being just x squared minus 9. So what's really interesting here is this is a subtraction and this is addition with the same two terms. And when you get this, you get what we call a difference of squares. This is a square, x squared is a square, and 9 is a square of 3, and it's a difference of squares. Isn't that a creative name? And so we have x minus 3 times x plus 3. And this is a very important structure in algebra and calculus going forward. You're going to run into this a lot. X minus 3 times x plus 3. You're going to end up squaring the x, you'll square the 3, and you're going to have the difference of x squared and 9. So this becomes x squared minus 9. If this was x minus 5 times x plus 5, you could think it through probably now, and you'd get x squared minus 25, which is 5 squared. X squared minus 5 squared. There would be a negative 5x and a positive 5x, and they would just cancel each other out. All right, I hope that was helpful.